All right, so yeah, what we need to talk about now is the conditional statements and the truth values. Because again, it's a component statement, and if-then statement is a component statement. So we've got P's are true, Q's are true, but P can be false and Q can be true or false. So we need to see how it all works out for this if-then statement and the truth values. All right, the way we like to explain it is, say we've got a politician. And the politician statement is this: if I am elected, then taxes will be lowered. Good example of an if-then statement. Okay? Well, all right, so what we want to look at then is, here's my P, here's my Q. We want to look at all the possibilities of the P's and Q's being true and false, right? Do a little truth table for that. Well, let's do it the way we've been doing it. P's and Q's, we could have a true, 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 false, false, true, false, false. Go line by line here. And the way we'll approach it, of course, is we'll say, figure out whether or not we can say the politician lied. And if we figure out the politician did not lie, we'll give him the benefit of the doubt and say he told the truth, okay, or she. Okay, so line 1, here's what happens. P is true, politician is elected, and Q, taxes will be lowered, is true also. Did the politician lie there? No. We would have to say the politician told the truth. Okay? So TROT is true, just like on all the others. Okay? Line 2, though. What do we got there? Well, line 2, true, the politician is elected, but false, taxes will be lowered. Aha! We've got them, don't we? What happened? The politician did tell a lie, didn't they? So their statement was false. Yeah, that one. So TROF is false. Okay, now, next two may be a little tricky. But here's what we got. P is false. Q is true. But again, we're approaching it. Did the politician tell a lie or tell a false one? P, I'm elected, is false. But true, taxes will be lowered. Did the politician lie? They did? If I'm elected, then taxes will be lowered. I'm elected is false. So they weren't elected. But it was still true, taxes will be lowered. No, the politician didn't lie there, did they? They never were elected. And we do give them the benefit of the doubt, okay? It wasn't because they were elected, but we can't say that the politician lied, can we? Because they weren't elected, you see. Now, the fourth one is really tricky. If you thought that one was tricky, this one's really tricky, but here's politician, I am elected, is false, and taxes will be lowered is false. Did the politician lie? Maybe, but we can't say he lied here or she lied because they weren't elected, right? Even though taxes will not be lowered, I'm elected is false. So did the politician lie? We don't know. We give him the benefit of the doubt, so to speak. No, it turns out that one's true also. Yes. Conditional statement is a little different than the and statement, a little different than the or statement, isn't it? To kind of summarize, right here is the one that's kind of different, isn't it? is the one that's false. The rest of them are true. T arrow F, that's the only time the conditional statement is false. It's T arrow F. Now, you have to be careful, because if it's F arrow T, is that one false? No, F arrow T is true. So if we revert, it's T arrow F. That's the order. T is true. The first part is true. The arrow to F, that's the one that's false. T arrow F. F arrow T is true. So if we reverse it, it turns out to be true. And then also note that last one. It's different than the and the or statement for sure there, because F arrow F is true as well. Even though the two parts of it's false, the statement overall is true, you see. So the arrow statement, it does have its peculiarities. But this is the key. T arrow F is the one that's false. The only time it's false. The rest of the time are they are true. Okay? So that's how the conditional works. T arrow F is the only time it's false. All right? Well, let's do a truth table then. Let's do another truth table. Get a couple of practice ones here. All right, let's do a truth table for parentheses, not P, arrow, not Q, and then arrow that with P. Okay? All right, so a couple of arrow statements to work on. But the truth table, again, always just starts the same way. True, 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 false. False, true, false, false. Okay. All right, so the way I like to do it is just write under each component, write its truth values all the way down. So not P is the opposite of the P column, so that would be false, false, true, true. Not Q, that would be the opposite of the Q column, so that would be false, true, false, true. And then P is just a copy of the P column, so it would be true, true, false, false. All right, so we do the parentheses first. So that would be the arrow statement there in the parentheses. So that would be, okay, so we start off right off the bat with a tricky one. What is this one? We got F, arrow F. True. That one's true, yeah. A little difficult at first to get that one, but yeah, the arrow statement, if it's F, arrow F, that's true because the only time the arrow statement's false is if it's T, arrow F. F, arrow F is true, F, arrow T is true, T, arrow F is the only one that's false. All right, what about F, arrow T? Is that the false one? No, it's T, arrow F that's false, so that one's true. TROF, that's the false instant, and then TROT is true. Got that? TTFT. All right, so now we take these two and arrow them up together. All right, so I've got TROT. I'll write it here in between them. That's true. That's the nice one of all of them. And or arrow, it doesn't matter. If you got both of them true, it's true. TROT is true. FROF is true. And then TROF is false. So I'm with TTTF. We almost, well, a lot of times it happens, but one thing, let me give you also here. One other thing that the book asks about are tautologies. Is it a tautology? Well, here's the way that works. If it asks you if it's a tautology, here's what it means. A tautology is a statement that's always true. Statement that is always true. That's a tautology. We're started out there to be a tautology because we didn't get the false to the fourth one, but yeah, to be a tautology, that last one would have had been a true. So if it winds up your column is all trues, that's called a tautology. And they ask sometimes about that. That's how you get one of those. Always true statement. All right? Of course, you can have a mixture. You can have ands with arrows, and say we had that. What would the truth table for this look like? P. Oh, let's do Q arrow P and not P. Q arrow P and not P. Same deal, right? Do P's and Q's, do the true, 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 false, false, true, false, false. Do the Q, we got true, false, true, false. P, you got true, true, false, false, just copying those two columns, and then not P on the end would be false, false, true, true. All right, so we arrow true is true, false arrow true is true, true arrow false is false. So yeah, it's the one is the true, the other's the false. That's the T arrow F, that's the false, that order. And what about false arrow false? Is that true or is that false? True, right? On the arrow, that one's true. Okay? But now we AND these two together. And what about AND? How does it work? For AND to be true, both of them have to be true. That's pretty much it. So true and false is false. True and false is false. False and true, though, is also false, because both of them have to be false for AND to be false. I mean, both of them have to be true for AND to be true. So false and true, that one's false if it's an AND statement. And then true and true is true. So you got to keep all the different ones separate there, how they work. Okay? All right.